let's have a look at 19. Okay, you got a 3-meter piece of wire is cut into 2 pieces and bent around to form a square and a circle. Find the size of the 2 lengths that will make the total area of the square and the circle a minimum. Okay, so let's have a look at the two lengths, right? So one of the lengths is going to be x. The other length is going to be y, or the sum has to equal 3 meters. So what would the other length be?
3 minus x.
3 minus x. Got it? Okay, cool. Now, so x is going to be like the length of the square, right? So what would be the equation that connects the side, one of the sides, with the length, the perimeter, x. X is the perimeter. You got side here, side here, side here, side here, right? They're all the same, yeah? So side plus side plus side plus side gives you
4s.
4s, and that's going to be equal to x. Got it? Because it's the perimeter. And that perimeter's got to be equal to x.
Yeah.
Got it? Yep. Cool. So what would the side be equal to?
X over 4.
X over 4. Good. Got it? All right. Now, let's have a look at this. The circle, on the other hand, has a circumference of 3 minus x, right? What would be the relationship between the radius and the circumference? 3 minus x would be equal to
2 pi r.
2 pi r. So what would the radius be?
3 minus x over 2 pi.
Got it? Now, what would the area of the first first shape be, and what would the area of the second shape be?
The area of the first shape would be s squared.
Yep. So total area is equal to s squared plus, yep, what else?
Plus pi r squared.
Pi r squared. Got it? Now, in terms of x, what was s again? X on 4. So really, the area of the first shape is going to be x on 4 squared. Got it?
Yep.
The area of the second shape is going to be pi times 3 minus x on 2 pi squared. Got it? S squared, that one squared. Yep. Now, altogether, the area is going to be x squared.
Can't you cancel the pi and 2 pi first?
Not quite, because you've got to square it first.
Oh, okay.
Yep. Plus, so that's going to be 4 pi squared, right? And then one of the pi's and one of the pi's in the pi squared are going to cancel.
Yep.
So it's 4 over pi. Yep. And then you got 3 minus x all squared. Okay?
Yep.
Now, then you basically put it all over a common denominator, which is, say, 16 pi. Yep. That'd be x squared pi plus, and then you multiply this top and bottom by 4. So let's square this. You've got x squared minus 6x plus 9. Yep. And then you put a 4 out the front. Got it? Yep. And then you've got 4 plus pi x squared, see what we've done, minus 24x plus 36 all on 16 pi.
Wait, I don't really. Wait, what did you get? 4 plus 5 from?
4 plus 5. Okay, cool. So this x squared term becomes 4x squared.
Wait, I don't know where you could put that.
Oh, okay, so what I've done here, let me just write it in red. Times 4 times 4. Yep. And then I've times pi times pi.
Yeah.
Okay? So you end up with x squared pi here.
Yeah.
And here you've got 4 outside of the square of this, which is x squared minus 6x plus 9.
Yeah.
Now, what's 4 times x squared?
4x squared.
Yep. And then you've got x squared pi here, right?
Oh, right. Right. Oh, okay.
Got it?
Yep.
Yep. Now, so eventually we've got a equals to 4 plus pi x squared minus 24x plus 36 on 16 pi. Got that?
Yep.
Now, we want when this area is a minimum. Yep. So basically what we're doing is once we've got this, what do we do from here? We want when a dash equals to 0 and a double dash is greater than 0. Do you reckon you can do the rest from here?
Yeah. Wait, why does it take a long time to differentiate?
What you can do from here, not so much this one, right? Because this, yeah, some of them do. Some of them do take ages, right? But this one here will look like this. So 1 on 16 pi just comes out the front. The rest of it becomes 8 plus 2 pi x minus 24 equals to 0. Because the 36 disappears, the x disappears, and the 2 just goes out the front, and the power becomes 1.
Okay.
Yep. Now, when we equate that with 0, we get 8 plus 2 pi minus 24. Whoops, 8 plus 2 pi x minus 24 equals to 0. Yep. So x is equal to 24 over 8 plus 2 pi.
Yeah.
Yep. Equals to 12
Zero.
on 4 plus pi.
Yeah.
Got it?
Yeah.
Yep. Now, that'll be the value of x. Yep. And then you've just got to work out the second derivative, or, oh yeah, the second derivative is easy, right? A double dash would be equal to, now, the 24 would disappear. Yep.
Why?
Because we're differentiating this.
Oh, yeah.
The 24 would disappear.
Yeah.
Yep. The x would disappear.
Yeah.
Right? So we're left with 8 plus 2 pi all on 16 pi. Now, is that positive or negative?
Positive?
Positive. Yeah, positive. Right? Therefore, it's a minimum. Got it?
Okay.
Not
Yep.
quite finished yet.
Oh.
Oh, we've
Alright.
got to work out the two pieces, right? So if
Yeah.
your first piece is x, right? That's your x. So your second piece would be 3 minus that. 3 minus 12 over 4 plus pi. Which ends up equaling, what is it? 12 plus 3 pi over 4 plus pi minus 12 over 4 plus pi. Yep, that 12 cancels with that 12, leaving you with 3 pi over 4 plus pi. So you got your two answers. That's one piece of wire. That's your other piece of wire. Add them together. They should give you 3 meters. Okay.
Okay.
But we got to find them to 2 decimal places.
Oh my gosh.
Yep. So you got to put that in your calculator and round it off to 2 decimal places.
So 1.68
Yep. Let's have a look. 1.6.
and 1.319.